Alright, so today we're gonna give you an introduction to what inheritance means and how it works. So we've been doing some classes, and they are, I think I mentioned it last time, we did something like and I'm gonna use this color so I don't have black. And we made our code here, whatever we did for the class. Then I mentioned that we have two types of variables. One is the primitive types and one is the object types, right? And I told you if it's not primitive, everything is an object. And Java, if you don't write anything here, uses this. It's implied. So this code, these two keywords are inside the Java class. It's Java SDK, JDK, I'm sorry. So when you compile Java, if you don't have anything like in here, Java will use this, add that code for you, and it will say class person is inherited or derived, depends on the textbooks you're using, from the class object. So what is this class object? So this class object exists in the Java Foundation class. And it says everything is derived or inherited with this class object. And this class object has, like any other class, it has a default constructor. That's why when you don't specify a constructor in your class, Java will use the one in here. So it has some methods here. And I don't know the code, but it exists. There's another method. There's quite a few methods. Remember when we did variable dot and then all this method showed up and some said class person, the other says class object. There's this other method that returns a string. And it's funny that the string is derived from the class object, but the object contains method type string. There's a method called toString. And when we use this method toString, remember when we just did a system that out of print line and we just put the variable name and it gave us the address, the object type and the address? So this is what it returns. Class type plus the @sign plus the RAM address where is. So this method does all that. There are other methods when we compare strings. When we compare strings, we don't use the double equal signs, right? Because if we do, we're comparing the memory addresses. We don't want to compare the memory addresses. We want to compare the contents of the object, and that's why we use this method called equals, right? We use that. And in the class strings, we have another version says called equals ignore case. Right? And this object, I'm sorry, this method takes another object and it'll return this will return so this object work this, right? If you work this, will compare the address with this other object. If they're the same, returns true or false. There are other methods. You can find them. I think it's 9.6 where it is. Let's see. There are other methods that we're not gonna use much in this class. There are this method called I'm just gonna list them here. This one uses generics, which is something you're gonna learn next semester. So you have the get type, you have wait, all, I think it says. No, notify all. It's notify and notify all. So I'm just going to talk about those methods. Oh, there's a hash code. We won't worry about this until next semester. But this just returns the type. So if it's not object, it will be type person or student, whatever it is. Notify, wait, notify all. They all refer to threading. You know what threads are? So if you do Alt Control Delete in your computer, you go to Task Manager, and you go to Process. You will see what is a little bit different. It's about threading, and Windows 10 doesn't give me the details as Windows 7 does. It tells you how many processes. Oh, there you go in the performance section. You have 178 processes running in my computer right now. It fluctuates. Open the Task Manager. You have to get to that. Alt Control Delete and Task Manager. Click on the Performance tab. And below the graph, you'll see processes, threads, and handles. You see that? So the processes are programs running. Threads are like mini programs. So like like, let's say, as a person, I don't know if it's a good analogy, your left hand and your right hand can do two different things, but they're all part of you, so that's like a thread. Handles are objects. How many objects are in there? So, what this does, wait, notify all this. Let's say there's a piece of data that if somebody is writing to it, another thread shouldn't be reading until this other one is done. And when it's done writing, it should notify all the threads that are waiting for it. Clone is just copies it. So we're going to focus just in these methods. The constructor, which we already talked about, the toString, and the equals, which we actually have talked about it a little bit. So, I'm gonna make, let's see if I have a RAM here. Let me show you how it works in the RAM. And I'm just gonna use 100 increments for simplicity. Alright, so if you have an object, the objects all are the same size. I mean, this class object. So if I say in my code, if I say I declare a variable type object, I'm going to call it O equals new object, it will come and allocate the size of an object here, right? Let's assume it's these two chunks. So it'll do this. Right? But let's say I made this class called person. And we know the class person is inherited from the class object. And how with my stuff. So if down below or somewhere I use person new, what's new person? So what this is going to do, the class person is an object, right? So the object's still there. But then I extended the class object to a class person. So the class person is going to come right here. This is the size of the class person. And it's going to sit on top the extension part. You follow me? What it extends. Then I make another class. Let's say I make a class student. And this class student is gonna extend person. So if I were to declare a student object, the compiler is going to say, well, the object is here, and I extended the person, and then I'm gonna extend the student to whatever size it is. So the student is a person, the person is an object, right? Don't you hate those tests when you go apply for a job and they give you this weird if this is that, then therefore this is something else, and I hate those. Anyways, so obviously the student is also an object, right? And they all start here. So at an address 1,000, what kind of object is sitting there? Is there an object type object there? Yeah, the green is the object. Is there a class person there? Yeah. Is there a class student? Yeah. They all refer to the same address, right? They all begin here. But then you have to know, that's why it's important, this new keyword allocates memory, and it's a contiguous amount of memory. That's why it just sits here. I cannot have part of the student here and part of the student there. It has to be all contiguous. What happens if there's no space? Then the operating system needs to make space. Start making pages and stuff, or using virtual memory, which is your hard drive. So far so good. Very intuitive. Almost, right? Until I give you a homework. So, let's say I don't have any code in these classes. They're just like blank. I have no constructors or anything. But I can still call this one new student, because the constructor exists in the class object, right? Bless you. So what's going to happen is, when you're using a class, when you're calling a method within a class, it's going to go look at the class itself, and it's going to come here at the end. It's going to go down, trying to find the method that you're using. So there's no constructor until the class object. You found one here, right? You're allergic to exams, right? So, but let's say I do make a constructor in my class student. In this, and let's say it takes us a string, it's one parameter. Then, guess what happens in this one? I get an error, because there's no default constructor. I made my own constructor. So if you look at the class scanner, if you do scanner, whatever, E equals new scanner, and you try to use the default parameter, the default constructor, I'm sorry, it's going to give you an error. Because once you make one, oh, there are constructors here. It will never reach the object class. So therefore, this one will require parameter, string, whatever you want in there. Make sense? So, at this point, I could do space here. So if I do that, toString, I don't have a toString method here. So it's gonna go to the student. Student starts at 1,000, and he knows it's this big. It's gonna come here and start trying to find the toString. Where is the toString at? It's in here, right? In the object class, so it'll be here, the very bottom. So it's just gonna print out the class name at the address where it was created. However, let's go and make some room. If I write another method called I can make my own toString. This one I'm gonna call it toString2 for now. And it's gonna return hello. So the toString, if I write toString2, it's gonna print hello because it exists in the class student. But if I write the toString, it's gonna go try to find it, and it found it here. But what if instead of calling it toString2, I just call it toString? And I call u.toString. It's gonna come here, gonna try to find it, and it's gonna find it at the student level. So it's gonna print this, it's gonna print hello, and then it's gonna exit. It will never reach the one on the object. So what we did there, this is called overriding. When you override a method, you are simply making a method with the same name of a method on the parent class. So the object is the parent class, and the class person is the subclass, right? Oh. So we call this parent, and obviously, actually, it will be child. Or we also call it, so we call this a subclass, and this one we call it superclass.
What does that mean for the student class? The student class is
It will be another child class. So the class person is a child of object and is a parent of person. And there's no grandchild or anything like that. Okay. But so this is a child or subclass of person. And this is a child or subclass of object. I can make another class with its own set of methods. So the beauty is whatever methods and variables I use here in person, I only need to add the difference. Like in the person will have a name, address, whatever. In the employee, probably all I need to do is add the pay rate and hire date and term date. And in the student, I need to add student ID and GPA or whatever. So you know every employee is a person, every student is a person, but doesn't mean every person is either or, right? Follow that logic? So, the nice thing about inheritance is I don't have to reinvent the wheel. So, in this class person, I could have my mutators and accessors to set the name and address. For instance, I could have, I'm just gonna do it like this because I'm out of space. So this class person has a name. So in here, I can do dot name. Because it doesn't exist in the student, but it exists in the person. So when it comes here, it's gonna start looking down until it finds one. If it doesn't find it, then you'll get a syntax error saying method not found or something along those lines. And we're gonna work extensively in inheritance. So, in this chapter, let's see. What am I, chapter 10. We're gonna hold off on chapter 10. We're gonna go to chapter 7, talked about arrays, and then we'll go to 10. And that's what we'll do next week. So, questions? So, if I ask you about this, you will know. There's something, I don't know if in the exam, but I'm gonna tell you. Sure it's not. This is the if statement. You know how to do if statements, right? But did I show you the shortcuts? I'll show you a shortcut. Well, you read the book, right? I mean, that's part of your homework, right? That's in the, to watch the Mighty Lab and do the exercises there. I hope you don't procrastinate until the end of the semester and try to do them all. Yeah. So you're supposed to, since it's a hybrid class, you're supposed to do your reading before coming to class. Don't expect me to give you everything. But in case I forgot, I'm going to give you a shortcut for if statements. I'm going to give you a simple example. And this shortcut works only if and only if you have a true and a false part. That means you have an else portion too. You need to have both. So let's say I have an int x, and I'm gonna give it 5, and then I use an if statement here. If, and I have an else portion. And I'll say if x greater than 10, print it's not right yet. Never mind. Let's do equal to 0. I'm going to say the negative number, and this is a positive number. That's a very easy if statement, right? But I can write all that in one line. And the syntax is, remember when we did the UML diagrams, we have a diamond and we have a question mark? So we're going to use that. So this will be my question mark there. And to separate the true with the false part, I'm going to use column. So what you write, something like this. So this is like this. It's equivalent to it's not gonna fit there. I'm gonna write it below. So this is equivalent to saying this. So So x is greater or equal than 0, then I use a question mark. And then if it's true, then I print positive. And if it's not true, it's a column.
It's false.
So this only works if you have both true and false, and you are returning only one type. There's no code here. I mean, you could put another if statement inside, yeah, in parentheses. But it's the same thing. So you'll see that in code when you do this for a living. Hopefully, I encourage you to do this. I mean, to get a job doing programming. Questions? I don't think I asked you about that, but in case I did, and because you read it already. Let's see, is it the book? Sure it is. So this is the logical, and it will be looks like it's chapter 5, 9. Maybe not. All right, let's take a break.